Hello mathematicians, we wrap this chapter up with a look at quadratic identities. Now quadratic identities seem to be a little bit unusual, but it's actually an important technique, and from the point of view of pure maths, it's a significant aspect of polynomials. But for us it's pretty straightforward. So if we have two quadratic equations, that one and that one, then as far as we're concerned, this quadratic identity section just says if those two quadratic equations are identical, which is what the triple barred equal sign means, then it probably agrees with what your common sense would tell you, that these things that are in corresponding spots, the A's, the B's and the C's, must be equal to each other. Now, more important than that fact is probably that we're going to look at a slightly different technique for solving these problems, which is going to be potentially more powerful. So again, we do have alternatives. So if we look at this example just here, where it says that 2x squared plus 5x minus 3 is identical to a quadratic written in that method there, we've got a way of doing that based on what we know already, which is that we could take the right hand side, we could expand out this bracket, we could expand out this bracket, we could gather together like terms, so we could gather all the x squareds up together, we could gather all the x's together, and we could gather all the constants, and we could write three equations and we could solve those simultaneously. But we know how much fun it is solving three equations simultaneously. So that makes this alternative method worth pursuing if we can. And so what this alternative method is built around is the fact that we look at the expression on the right and just imagine that there may be some values of x that we could substitute in, because we know if we substitute them into one side of the equation, we should get the same result as if we substitute them into the other side, because they're identical. But what we're looking for are values which we can substitute in, which give us a whole lot of simpler options. So this textbook guides us through a few of these. So if we substituted x equals 2 into this identity first of all, you can see that if I put a 2 in here, this bracket and this one becomes zero. So all that I'm left with on the left-hand side is C. And when I put a 2 in over here, that's no big drama. I've got 2 times 2 squared, so 2 4s are 8, minus 10, so that's negative 2, plus 3, so that's plus 1. So I get the value for C straight up. Now, even if that was all I could do, I could plug that in and all of a sudden I'd be only solving 2 equations simultaneously. So that's really a lot easier than 3 equations simultaneously. However, there is another trick, which is that if it's possible, we can equate the coefficients of x squareds to find the value of a. So if I look at this here, if I did expand this bracket out, we know it would just be x squared. So on the right hand side, I would have ax squared and a whole lot of other stuff. And on the left hand side, I've got 2x squared. So therefore, obviously, a equals 2. So I've got 2 of those coefficients. Now, if I know 2 of them, then I could find the third just by subbing in and solving an equation. But again, there's one other trick we might be able to do. It's probably not all that much time saving now, given we've got 2 of these. But if we put x equals 0 into the identity, I could then find the value of b. So in part C, knowing that c is 1 and that a is 2, on the right hand side, if I put x equals 0, that will give me minus 2 squared, which is plus 4, multiplied by a, which is 2, so that becomes 8. If I put 0 in here, I've got minus 2b, and I put in my value for c, which was 1, so my right hand side just says 9 minus 2b. And on the left hand side, when I put x equals 0 in there, that just gives me 3. So therefore I've got that 9 minus 2b equals 3, so 2b equals 6, so b equals 3. So that's been a lot quicker. It's taken more thinking, but it's been a lot quicker and less, hopefully, error prone than expanding it out, setting up 3 equations with 3 unknowns and solving those simultaneously. So have a go at the exercise, see how you manage.